Okay. Let me turn the headphones up. I feel like that was like you know in songs in like 2012s, early 2000s or early 2010, where it's like Lil Wayne, turn the headphones up. Okay, so guys, we're diving into the algorithm Sunday episode. I'll be honest, it has been tough. It has been tough juggling a few different things. I'm studying for my AWS cloud cert, so hopefully I heard that's not too bad. I've been rewriting some cover letters and stuff. Boom, cover letter. Boom, resume. Look at these two. Boom. He's a professional. Yeah, doing that, and then doing an interview prep course as well, and then obviously studying a ton of other stuff too, and building our lovely project management system. So it has been tough doing all those things, and obviously the YouTube channel as well is its own deal. But I like it tough. I like the challenge. We're here for an Algorithm Sundays episode. Or an algorithm. The one we're going to go for is going to be, I believe, an insertion sort or a bubble sort. You can see I've already done it, but I'm going to do one of them or both of them in JavaScript. I know. I said I'm going to do this in Python, but it has been a pain to do in Python, guys. I'll be honest. It's just not my go-to versus my bread and butter over here is a lot better. So we got to decide which one. Do we do bubble sort or insertion sort? Insertion. It looks like we haven't done this one, so I'll go ahead and start it then. Let's think about it. So different sorting methods. What I understand insertion sort is we're gonna have an array. Well, I guess first let's talk about different sorting methods and why they even exist. So different sorting methods exist because they're gonna be used for different cases. Maybe you get chunks of data in an array or an array of objects of data, right? But for this case, we'll just pretend it's just numbers. Maybe that data is pre-sorted. Maybe you have an array that looks like this, and you get a new value, and the new value, let's say, is 2.5 or 2.4. You probably want to go with an insertion sort, where an insertion sort is going to look through the algorithm or through the array and then say, okay, I think it goes here, and then put it there. It'll say, okay, 2.4 is larger than this 2, and it's smaller than this 3. Let's put it here. So that's one sort. Bubble sort, for instance, I think bubble sort would take an array of, let's see, 6. We'll say 5 or 3, and we'll say 4, 2, and 3 there. I think bubble sort would start from the back and say, okay, are these two numbers comparable? Which one's bigger? Oh, the 6 is bigger than the 3. Okay, then pass the 6 here, put the 3 here. And then it'll look at these two numbers. Okay, which one's bigger? The 4. Okay, then put the 4 here and the 3 here. And then it'll look at these two numbers. Which one's bigger? 3, 2. Okay, and then which one's bigger? Boom, this 3. So swap. Boom. So they're different sorting methods. I don't think bubble sort's actually used very much, but insertion sort obviously is one. Merge sort is another. Merge sort is a lot different, where basically it's going to divide and conquer. We'll pretend we have an array of 6 values, and basically it'll break this array up into 2 arrays. So it'll say, okay, let's look at these 2 values, even though you still have this main array above. This is kind of what insertion sort is doing under the hood. It'll break them up, and then it'll even break them up even more. And it'll say 6, 2, and 1, and 9, 8, and 6. And then it'll try to sort these 2 arrays first to its smallest values. So then it'll do the same thing. Actually, I think it literally breaks it down until they're just one arrays. I think is how the algorithm technically recursively works. So 9, 8, and then 6. And then technically these individual arrays are sorted, but then it sends it up this tree and it says, okay, now I need to merge these sorted arrays. So then it would do this. It would send the 9 and 8 like this up the tree, and then it would send the 6 over here still, but it would need to merge the 6. Or forgive me, I don't remember how many steps it would go on an odd number, but let's pretend this has one more number then. How it would work, it would send this 9 and 8 up, and then it would it would sort this 4 and 6 on this side, and pretend the left side also has a fourth number too. And then at this level, it would take these two arrays and then it would compare the two and say, okay, well, let's send it up one more. Let's merge these together. And it would obviously merge them in order. So it would say 4, 6, 8, 9. And then same time, the left array should be doing the same thing. So let's again pretend there's another number here. Yeah, so basically there's a lot of different ways to merge or to do sorting algorithms, right? And then of course it would pop this up, and there's gonna be different use cases for each. But I do believe, what would this be? It'd be 1, 2, 3, and then 6. So that's how the merge sort would ultimately work. You'd get these like two arrays on each side, and then it would finally combine those two, no different than how those were being sorted and merged to 1, 2, 3, 4, I believe 6, 8, 9. I might have missed one, but I think we get the idea. So there's definitely a lot of different ways to sort and merge things, or just sort things in general. But insertion sort again is I believe going to be more something like this. Like you're going to receive a target value, more than likely, and then it'll be 4, and then you want to insert it amongst the already sorted array, I believe. So let's I was gonna say let's read what insertion sort is, but just watch the video. But end of the day, basically we're gonna output a sorted array. Let's go ahead and start. I think the first thing we want to do is define some sort of minimum index. I do roughly know the syntax for this, I believe. So let's find a minimum index, and then let's loop through the array. Or I guess tomato, loop through the array, find the minimum index. But when we loop through the array, we're going to go through each thing. We need 2 pointers. Basically, we have 1 pointer that's going to go to the array values, and then we need a J pointer that goes comparing the first pointer, what the value's on, to the J index. So we have the I pointer and then the J pointer saying, okay, here's our array, boom, 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 boom. And then we need to loop through and check the numbers to that first pointer. So we'll say loop through array, say loop through J, which equals I plus 1. Because really it should just be the value to the right of it, or all values to the right of it. And then this will need to be the array length, and this will need to be the array length as well. I believe this will be array length -1 because we're going to do the J pointer, which is going to be I plus 1. So we need to leave room for the... Guys, I'm getting okay at the algorithms. I still need work to do, but I'm getting a little bit better. I've noticed that. I'm getting a smidge better. Still have work to do though. Still have work to do. This is only like 2 weeks in of half part-time studying it, right? I'm going to be taking it a lot more serious over the next 2 weeks, I believe, because of this program that I'm in. Okay, so let's think that. So we have this. We're going to loop through the I array. We're going to find the minimum index. We're going to loop through the J array. And then we want to write an if clause, like an if statement. If the, let's see, array min index is, I want to say greater than array of J, then do this. Then min index equals J. Oh, no, less than, right? I believe, right? Less than. So if the minimum index is less than J, or do I have this backwards? If the J value is less than the minimum index, there we go. That's the right logic. Okay, so if the J value is less than the minimum index, the new minimum index becomes J. That's, I believe, the logic. Okay, then what else do we need? Then we need to flip if minimum index does not equal I. So if this case happens, we now need to do the swap. So if minimum index does not equal I, right? We need to what's it going to be? Swap the, we'll see, folks. There might be a few bugs on this, but let's see. We'll see. We need a temporary value, temp index equals, or temp val equals array of I, and then the array of I needs to equal the array of minimum index. And then let's see, array of minimum index needs to equal the temp value. Boom. Okay. So I think that's going to be most of our logic. And then finally, of course, return the array. So first, I think that's going to be a decent approach. Let's kind of write it out and see how it goes, right? So for let, let's get the loop going. So for let I equals 0, I equals array dot length -1, I plus plus, and we'll say let min index, min idx equals for let j. So the loop within the loop now with the array dot, and of course j plus plus. Keep iterating through. So, and then we're going to write our little if statement. If array of j, so the jth number is less than the array of minimum index, or basically do something, which is going to be min index equals j. Let's return the array just so we don't forget that. And then I believe, would it be in this for loop that we do all this logic? Let's think. So would it be here? Would we do it in the j loop, or would we do it in the I? I think it would be here, guys. So if array, if min index does not equal I, we want to do something. Let temp val equal array of I, and array of I is going to now equal the minimum index, and the array of minimum index is now going to equal the temp val. So we're going to do a little swoopy swap, right? Let's see how that goes. Let's see how this goes, and let's get this test out of there. Okay, let's think. Array of j, minimum index. Let's run the code. Okay, we didn't get one right. Golly fucks. What is the raw output? Okay, array is not defined. Oh, I see. Boom. Array is not defined. Array. I was gonna say, Jesus. Oh, I didn't mean to submit it. I meant to run it. Let's see. Oops, one of your code's not working. Okay, well, let's see which one. Oops, there is an issue with your code. Test case 1. Let's see. Index, where's our issue? So we have I equals boom, min index, array of j. We're reassigning the minimum index. If the minimum index does not equal I, do this. Let's go to Code Sandbox real quick. And I'm going to console log some of this and see where our issues are. We just want vanilla JavaScript. Oh, no, that's the project management system. Don't need that right now. Okay, so we are just going to do, I don't even want this. I just want the JavaScript IDE looking thing where it's like 3 columns, HTML, CSS, JavaScript. Let's see. Come on. Try for free. Let's see. Oh, they must have changed it then. Okay, that's fine. We'll run with it. Or better yet, we'll just use the project management system. So, because it's already up and running, we'll just use, let's see, we can go to the dashboard page, and we'll just use this area right here, and I'll console log this, insertion sort, and let's give it an array of 4, 2, this, that, and boom. So we have enough material there to work with. Let's pull up the console. Guys, I really thought, oh, here we go. Temp value right there. There's an array we missed. Let's see if we at least pass something, right? Test case 139 killed the wrapper. Why? Okay, we got this. Let's go to dashboard, pull up our console. See the PWA is going off right now, which is great. I do have some news with this application as well. I do have some news. I do, which is great. Let's just see if it'll load real quick. Obviously, it's taking its sweet old time. It might be because we have this loop going. Could be crashing the server for all we know. But I really thought that was an insertion sort, or is that a selection sort? That might be a selection sort. That might be why. That would kind of make sense. I think this is actually a selection sort. So let's pop over to selection sort and see if this is our selection sort. I think it might be. Nope, there's still a raw output. 1930 selection sort. Golly. And of course, our team syncer is down. Why? Everything's just broken right now, you know? Well, golly, folks. We're going to figure it out. Or we'll pop over to bubble sort even. But bubble sort is an interesting one, right? And I think I can do it off rip. Let's see. Array.length. Let's swap. Let's see if I could do this. Return array. Do we return the array? Maybe I won't be able to do this off rip, but give it a go. For let I equals 0, I is less than n minus 1, and I plus plus, n minus minus, boom, boom, boom. First thing we do before doing that is swapped equals false. Should probably do that up there, and then let's see array. Let's see if array of I is greater than array of I plus 1, right? Or maybe it's n. I don't know, we'll mess around with it. Then we want to do this swap, and then we swap the swapped to true. And the swap is just going to be let that temp equals array of I, and array of I is going to equal array of I plus 1, and array of I plus 1 is going to equal the temp value. Let's see if I was able to do that. Hold on. Off rip, folks. Well, golly. All right. So that was redeeming for me. That was awesome. That was redeeming. That was very redeeming for me. Our server's still down, but we at least got bubble sort out of this episode. So I'm going to wrap it up there on a win. I'm going to wrap it up there. Guys, thank you so much for watching. I know it was supposed to be insertion sort or selection sort. Looks like I'll need to do some more homework on some algorithms. Fortunately, I got the bubble sort down. Yeah, so, but I will be doing more homework. That is certainly for sure. So thank you guys for watching.